Hi, my name is Benjamin Wilson. This is my video lab report for Lab 4 Circuits for Physics 2212. As an introduction, the purpose of this lab is to predict the behavior of circuits containing resistors in series and parallel, use multimeters to measure actual values of mutual current and potential differences in the circuits, examine the behavior of ohmic resistors and capacitors, and the fundamental physics concepts that were fundamental in the conducting of this lab can be seen listed below. In general, for this lab, the model and assumptions that were used include the following. For the model, I did this lab online using the PAGT circuit simulator. Um, the main assumptions used for the purpose of this lab were that there is negligible or zero resistance for the wires and emitters present in the lab, and the system and surroundings for this lab were the circuit was the system and the surroundings were everything else. As previewed for the results, generally speaking, the experimental results were consistent with predicted and theoretically calculated values, and in the final part of the experiment, the value of RC was calculated to be 5.97 seconds. In the first part of the experiment, our initial conditions had us set or connect two batteries of 1.5 volts, two emitters and two resistors, one of 47 ohms and one of 100 ohms in a simple series circuit. And in For this part of the experiment, I was tasked with predicting the current initially for this setup, which I predicted to be 0.02 amps, as can be seen there. And when experimentally conducted, it can be seen in the top right picture that is the current that was actually actually calculated. When you flip the emitters um, around for their connection, they read the negative of the original current. Um, for the second portion of this first part of the experiment, we replace the emitter with a voltmeter, and because the circuit is open, the current can't flow, so the emitter reads 0 amps, and the voltmeter reads 3 volts because the potential difference is just from the batteries. As we continue on in this first part of the experiment, um, I was to calculate the potential differences at the different points that can be seen in the image shown to the right, um, and then predict what the total potential difference should be um, when going through a full round trip in the loop of the series circuit. The calculated potential differences can be seen here, and my prediction was that it should equal 0 by the time you come to the end of the loop, which my experimental results were consistent with, as you can see when adding up all the different potential differences. Across all these points, it does in fact equal 0, which is consistent with the loop rule. Um, the current of this circuit was still evaluated to be 0.2 amps, despite the connection of the voltmeter, because the high resistance of the voltmeter disabling the current from flowing through it. And as far as when we replace the voltmeter with an ammeter in parallel with the 100 ohm resistor, the current ends up increasing to 0.6 amps because it naturally flows through the path of least resistance, meaning it doesn't pass through the 100 ohm resistor, and as a consequence, the resistance present in the circuit becomes less, and consequently, the current increases. And then I was also tasked with calculating the new resistance of the different circuit components based off of the potential differences um, and the current present in the circuit, and this is what I calculated. For the second part of the experiment, we used materials the 10 ohm bulb, 20 ohm bulb, 9 volt battery, and 200 millifarad capacitor and voltmeter. And general observations were that when the capacitor was charging and being discharged, the light bulb quickly lit up and quickly began to dim until it was not lit anymore. In both instances, the current was at its highest initially and then logarithmically decreased as time went on. The 10 ohms bulb took 15.2 seconds to charge and discharge, and while the 20 ohms bulb took 27.4 seconds to charge and discharge. Um, for the final portion of this experiment, we took that same simple series circuit connecting the uh, battery, the bulb, and the capacitor, and we evaluated how the uh, voltage decreased um, in the circuit over a span of 20 seconds, and we then graphed that in a linearized form. Um, in order to uh, get a understanding of um, how it changes over time uh, with respect to time. Um, Overall, setting up this plot and this graph, we're able to understand that the slope represents -1 over RC, and that way we were able to calculate experimentally what our RC equals, which was 5.97 seconds versus our theoretical calculation being 6 seconds. This can be accounted for with the human error that was present on my part, as I likely had inaccuracies when evaluating what the voltage was at specific time intervals. Um, Finally, for the what ifs, for the first question, if we use real emitters, then they would likely have some resistance present, and this would affect our evaluation of the current in the experiment. And then for the final question, how quickly would our ideal model predict the capacitor to reach full charge? I and would this prediction happen in real life? To answer this, I would say that it would happen instantaneously. Um, as a consequence of how fast the electrons move. Thank you.